Hi everyone, this is your video with sample free response questions for the ideas contained in designing experiments. I'm going to go through three different example problems for you here. They're all old free response questions, so if you want to look at the scoring guidelines, you can find them online. I put the year of the problem and the question number if you want to look those things up on your own. If you hear anything in the background, I apologize. My dishwasher is running. So let's go ahead and jump into these. All right, so let's take a look at this first one. Very common type of problem here, as you'll see as we go through, because what they want us to do here is talk about or design a completely randomized experiment. That is a very common question that is asked for free response. And then they ask later to ask us to incorporate blocking and change our experiment to incorporate blocking. This is a very, very common duo of free response parts in stats free response questions. All right, so let's read this and actually look at what's going on in this particular problem. So here we're talking about cholesterol, okay, and they're saying that it can be reduced by exercise or by drug treatment. Okay, so one of the two. Okay, so we have this company that has created a new cholesterol drug, and they want to compare the effects to the old drug, or the one that's currently on the market. Okay, and they're dealing with some volunteers who have a history of high cholesterol, who are not currently on medication, that are recruited to participate. Okay, so part A just says explain how you would carry out a completely randomized experiment for the study. All right, so for a completely randomized experiment, whenever you are asked to do something like this, you can go through and describe everything. Like, you can write it out in bullet points or in paragraphs, or you can draw an experiment diagram, which I have one that I made in a different software that I'm going to put in here so that I don't have to draw it directly on here. Okay. The key thing, though, if you're going to use a diagram, is that you have to describe how the random assignment occurs. Okay. And one other thing that I'll note for you here is that they haven't specified how many people, how many subjects there are for this particular experiment. So if they don't tell you, you don't have to include that necessarily, like the sample size, but it's usually a good idea to note that you want a larger sample size if possible. All right, so I'm going to pause my video really quickly to input my diagram, and then I'll kind of walk you through it and explain it. All right, so I'll see you back here in just a second. All right, y'all, so here is my drawing of a completely randomized design for this experiment. All right, so there's a couple of key things that I want to point out to you. First, okay, that they've included this, the random assignment of subjects, and then I went and explained how the random assignment would occur. Okay, so remember, random assignment comes first. It splits our subjects into two groups, right? And then another thing that you have to make sure you identify is what the individual treatments are. So here I did treatment 1 as the old drug and treatment 2 as the new drug. You could have added a third arrow here, a third group, to be the placebo group if you wanted to, but that's not necessary for this experiment. But you wouldn't get any points marked off if you included it. So it's kind of up to you. Okay, and then the last thing that I want to make sure that I point out is that I included this compare cholesterol levels. So you always want to have this step at the very end, the compare, and then compare and put that in context, right? So I'm not just, I wouldn't say comparing treatments, even though I am, right? What I'm comparing is cholesterol levels, okay? And then, like I said, if you are not going to write out how you are going to do this experiment, if you're going to draw a picture or a diagram like I did, you have to explain how the random assignment occurred. Okay, so what I wrote for you here is the general description for really just about any question like this that you can use that will work. Okay, so number your volunteers from 1 to n being the sample size. Use a random number generator to select n divided by 2, so that's like half. So that many unique random integers, right? Unique is a very key word here because it indicates that we're not going to select someone twice, okay? After that, the subjects corresponding to those random numbers go in group 1 and receive treatment 1, which in context is the old drug, and then all other volunteers will go into group 2 and receive treatment 2, which is the new drug. Okay, so the 3 things that are numbered up in the diagram right here, number 1, the random assignment of subjects, 2, the context of the treatments, and 3, the comparing in context, those are really the 3 elements that you have to have when you are describing how to carry out a completely randomized experiment. All right, so let's go ahead and look at part B here, which says, describe an experimental design that would improve the design in part A by incorporating blocking. Okay, so remember, when you block something, before you randomly assign subjects to treatments, you have to split them into homogeneous groups. So meaning the group should have, everyone placed in a particular group should have something in common with everybody else in the group. They should have a common trait. And you choose your blocks based on how you think, or you choose your blocks based on what characteristics you think might affect the outcome of your experiment that might possibly confound your experiment, that might be confounding variables that could be entwined with your treatment in such a way that it would be difficult for you as the statistician to distinguish the effects of the treatment that you imposed on the subject to the confounding variable or the characteristic that you blocked off. Okay, so here in this problem, they gave me a clue that in the very first sentence it had said a high cholesterol level in people can be reduced by exercise or by drug treatment. So that gives me a hint that exercise would be a good variable on which to block, a good characteristic on which to block. But there's lots of other characteristics that you could use. You could block by age if you think that age is going to affect how people respond to this cholesterol drug, what their general diet and health is. You could do it by gender if you think that gender might affect what's going on, like how the drugs treat the cholesterol. The key though is that you have to explain how that particular characteristic could affect the outcome of the experiment that doesn't have anything to do with the treatment that you imposed, right? The drug. What's the issue? Why are you blocking on that? Okay, that explanation does not have to be very long. It can be as short as, we want to block by gender because males and females might respond differently to the 2 cholesterol drugs, right? It can be that short. Or you should block on amount of exercise because exercise was shown to reduce cholesterol levels. Right, that's a perfectly good explanation. So, like I said, I have another one of these drawings that I've already done. So I'm going to pause the video quickly and insert that drawing, and then I'll talk you through it. So I'll see you in just a second. All right, you all. So here is my drawing, my diagram of this experiment with blocking. So I decided to block on exercise level. Okay, so that's what I did. You start with your main group of volunteers, divide them into blocks first, then do random assignment within each block into treatment 1, treatment 2. Again, notice that I'm still using the context, right? I'm not just calling these treatment 1 and 2, I'm calling them old drug and new drug, okay? Then within each block, you compare the cholesterol levels. And then one thing that I did not include that I probably should have is one more step here that says combine results. Okay, like so combine your block results. It's usually a good idea to include that last step as well. Okay, and then again, notice that we're talking about, it says describe an experimental design. So just the drawing, just the diagram is not enough. You have to explain why you chose the block that you chose. And like I said, it can be a very, very short explanation, like a sentence or two is sufficient, okay? And I said block based on exercise level. Because exercise is known to reduce cholesterol, those who exercise frequently may respond differently to the old and new cholesterol drugs. And I really should have included here. Uh, so those who exercise more frequently may respond differently than those who don't exercise often. Right, so I want to make sure I'm using the comparative language to compare the two blocks, okay? And then the other thing that you have to make sure that you include is your explanation of the randomization, okay? So up here in your diagram, what you would do is just put a little asterisk so that the AP readers know where to go, right? And then you're going to use the exact same language that you used in part A, but you'll do it within each block. So you would say number volunteers in block 1 from 1 to N, use a random number generator, ... It's the same verbiage as what you see at the top of the screen. And then all you have to say is, you don't have to write that all again for block 2. Just say, repeat this process in block 2. And then if the sample size is different, you would just say, you would include a little note that says, with N equals blah, 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 right? Okay. All right, so let's take a look at the very last part of this one, which says, can the experimental design in B be carried out in a double-blind manner? Explain. Okay, so remember that double-blind means that the people who are participating in the experiment, so the volunteers, don't know which treatment they are given, and that the person collecting the data does not know what treatment each person in the experiment received. So that is definitely possible in this scenario. So always answer the question. The question is, can this be carried out in a double-blind manner? So the answer is yes. Okay, and then you have to describe how each group can be blinded. Okay, so the subjects can be blinded by giving, or not by giving, by taking the, no, that's not the best way to describe this. So the subjects can be blinded if the two drug treatments look identical, right? So they aren't aware which drug they are taking. Okay, so that's how the subjects can be blind. And then you would say those administering the drugs, or you could say those monitoring the results or collecting the results, something along those lines, okay, can be blinded using a similar technique. I.e., they can't know which drug each subject is receiving. Okay, all right. Obviously, those who are analyzing the data have to know, but those who are collecting the data don't have to know. All right, so that is this FRQ. And so give me a second to clear my screen, and then we are going to jump in and try another one. So I'll be back. See you in just a second. All right, y'all. So here we are at our second FRQ on experiments. So I picked this one partially because of the very, very long explanation that they give at the beginning. Okay, this is a very common thing that they will do in statistics questions. They like to write out the entire scenario for you, hoping that you will take a lot of time to read the entire thing and then not have enough time to fully answer the questions that they are asking. Okay, so if you see a bunch of text like this, or a big long paragraph about the situation, it's a good idea to skim the first paragraph just to get an idea of what's going on, and then go straight to the question. Right? You can always go back into the explanation later and pick out other important information that you need. Okay, so skimming this very long paragraph here, we're essentially talking about a treatment with magnets to reduce pain. And then they described the whole experiment that they did. And now they're saying they want to do a new study to see if the same idea, if the magnets can reduce pain for herniated discs. And then really the biggest key piece of information here is this, that you have 100 male patients that are available for a new study. Okay, so part A says describe an appropriate design for the study. So again, this is very similar to the first one, where we want to design an experiment for this this new study with using the magnets for herniated discs. Okay, and then it gives you some information here, which says your discussion should briefly address the treatments used. Okay, so you how, like, what are the treatments that you are assigning to people at random? Methods of treatment assignment, so that means random assignment, so describing your random assignment, and what variables would be measured. Okay, meaning when you compare the results at the end, what are you actually going to measure? Right? What are the people taking the data going to record? Okay, and then it says do not describe how the data would be analyzed. Okay, meaning you don't have to talk about, like, then after you analyze all the data, put it in a histogram and look for mean and standard deviation, and you don't have to do any of that. They just want you to describe how you would conduct this study. Okay, so just like the previous question, I have a diagram already, so give me a second to include that, and then I'll see you back here in a second and I'll talk you through it. All right, you all, so here is my experimental design diagram. So I started with my random assignment of subjects, divided them into two groups with my two treatments, the magnets group and the no magnets group. Okay, or you could have called it a placebo, right? And then at the end, you measure and compare the variable that you're looking at here is self-reported level of pain, right? Um, that's how most of these pain studies are done in the medical field. Okay, and then I put a little note for you at the bottom here. Okay, that says we want to make sure we actually answer the question. Right, so they tell us what they want us to talk about in the question. They said address treatments, method of treatment assignment, and what variables would be measured. Okay, so your treatments here are magnets and no magnets. As long as you include them in the diagram, you don't have to specifically write them underneath because you've already included them here, right? One thing, though, that you may want to include is what this would look like for the magnets versus no magnets if you were going to try to incorporate blindness somehow. So that's what I wrote here that's highlighted at the moment and in bold, that the way that you would do that is that the subjects in the no magnet group would be treated the same way as those in the magnet group. So they would go through the same process, but there just wouldn't be any magnets embedded in the pads, right? Which allows us to include those ideas of blindness, okay? So that's the treatments part. Then methods of treatment assignment is random assignment. So how would you do the random number assignment, right? So that's the number of the subjects from 1 to n. Use a random number generator, right? You'll have written these so many times that you'll kind of get sick of it. Okay. And then the last thing that they said we should talk about is what variables would be measured. Okay. And like I said, that's self-reported level of pain or reduction in pain, which I included in the diagram. So if you include it in the diagram, you don't have to explicitly write it out. I just did underneath here so you could see these are the 3 things that they want us to talk about. So I want to make sure that I include some explanation for all 3 of those things. All right. So let's take a look at part B, which says, would you modify the design if instead of 100 male patients, there were 50 male and 50 female patients? If so, how would you modify it? If not, why not? Okay, so believe it or not, you can get this part right by arguing both yes and no. If you're going to argue no, that you're not going to, so if you choose to argue no, right, then you have to describe why you wouldn't change the design, right? So a reason for that might be that randomization should equalize the effects of gender in the 2 groups. Oops, forgot a there. So this is a possible explanation. You can totally hear my dishwasher in the background there. Okay. Or or you could talk about how or you could say we can assume gender doesn't, I'm really struggling with my typing today. Gender doesn't have a strong effect since the sample size is large. Okay, so those are some possible explanations that you can use. I think that what they want you to do here is answer yes. So if you choose to argue yes, okay, again, you have to explain why. Okay, so how you, so possible alterations. So how would you modify the design? So you would have to say, you would basically have to describe blocking, right? So you would say, separate the subjects into the 2 gender groups and randomize subjects to the 2 treatments within each block. Okay. You could draw a blocking diagram if you wanted, but you could also just write it out this way. Okay. I personally think that arguing yes for this question is an easier sell, and it's an easier thing to explain, because they essentially give you the blocks, right? They give you the gender blocks by saying we're going to split into 50 male and 50 female patients. Okay. All right. So I've got one more FRQ for you. Just like the previous one, I'm going to take a second, clear my screen, and I will see you back here for the last experiment FRQ momentarily. All right, you all, so here's your last experiment sample FRQ. This one is a little different than the other 2, but this is another common type of experiment question for an FRQ. it has you look at and identify what the variables are, the treatments, experimental units, and kind of talk about the principles of experimental design, right? So remember the replication, randomization, comparison, etc. All right. So let's go ahead and jump into it. This, when you first look at it, again, is another really, really long explanation. So just skim the explanation to get an idea of how the experiment was conducted and then go straight to the questions, okay? So here in this scenario, we're essentially talking about how tractors plow, plow fields. Okay, so they're saying that they have designed a study to determine which type of hitch, which is a like an attachment. It's a tool that people use when they plow. Would be able to reduce draft compared to the standard hitch. Okay, and then they talk about how they conducted the experiment. So they said 2 large plots of land were used in the study. So they're only using 2 plots of land. It was randomly determined. Okay, good. So we have some randomization in there. Which plot was to be plowed using the standard hitch? So then obviously the other plot would be plowed with the new hitch. Okay, right? They said a measurement device recorded draft at 25 randomly selected points in the plot. Okay. And then it says after the plot was plowed, the hitch was changed from the standard to the new one. Then they plowed the second plot with the new hitch. Okay. And again, they took the 25 measurements of draft. Okay. So this first part, part A, is just having you identify some stuff. So first, they want us to identify the response variable, which is, remember, that's what you are measuring, what you are concerned with measuring as the statistician, as the scientist. So the response variable here was the amount of draft. That's what we're measuring. That's what we're concerned with. That's all you have to write. You do not have to write it in complete sentences. You can just identify what they are, okay? Then it says identify the treatments. So the treatments were the 2 hitches that they used, right? Remember, the treatments are the types, right, or the groups essentially that you're putting your experimental units in and what you are changing, right? So the explanatory variable here is the type of hitch, right? That's what you are changing as the scientist. So the treatments are those 2 hitches, right? So you would say it's the standard hitch, which was like treatment 1, and the new hitch, which is like treatment 2. Okay. And then the experimental units is the smallest unit or the smallest subject that you can apply a treatment to. Okay, so you have to go back into the question and look at what are they actually applying the treatment to, which is the hitches. And they're not applying them to different parts of the plots. It's not these 25 randomly selected points. It's the whole plot, right? The whole plot of land either gets the standard hitch or the new hitch. Okay, so the experimental units were the 2 large plots of land. Okay. All right, let's look at part B, which says, given that the goal of the study is to determine whether a newly developed hitch reduces draft compared to the standard hitch, was randomization used properly in this study? Okay, so basically they're just asking you, did they include randomization? And they did. They used it correctly, right? They chose one of the plots at random to receive one treatment and then gave the other plot the other treatment. Okay, so you would just say, yes, the 2 hitches, which were the treatments, i.e., the treatments, okay, were randomly assigned to the 2 plots of land, i.e., the experimental units. Okay? That is all you have to say. That is all you have to talk about. All right? So let's take a look at part C here, which says, given that the goal of the study, okay, so they just repeat what they said before. Then they're asking, was replication used properly in this study? Okay, so as a reminder, you wouldn't write this. This is just a reminder for you. Replication requires that each treatment be received by more than one experimental unit. Okay, so even though they gathered data points, for example, right, at 25 different points in each plot, there's no replication here, right? It doesn't exist in this study because replication requires that each treatment, so that would be the different types of hitches, be received by more than one experimental unit. So in this case, you would have to use the standard hitch and the nude hitch on more than one plot each, which did not happen here. Okay, so to answer this question, you would say no, each treatment which is the type of hitch, was applied to only one experimental unit each, which was, remember, your experimental units were the plots of land. Okay, right? So you would essentially then, you may want to add like one other sentence here about why there's no replication in this study. Okay, so you can say something along the lines of really what I said in the reminder, which was replication is used to repeat the treatments on different experimental units so that we can observe patterns, right? And there's and then you can just tag on at the end if you want. There is no replication in this study. All right. Last part here. It says plot of land is a confounding variable in this experiment. And it asks you to explain why. Okay. And it all goes back to this idea that we only used one experimental unit. Okay. So it's difficult for us to know, or really almost impossible to know, if the hitch, right, the treatment that you applied was the thing that was affecting the draft, or if it was just because one plot of land was better for draft than the other plot of land, just because of its other characteristics. Okay, so the way that I would talk about this is you want to include in your explanation how plot of land could affect the outcome of the experiment. Okay, right? So you would want to talk about how the difference in the draft, you would want to talk about how it's not possible for you to know if the difference in the draft was observed because of the treatment you applied, or because of the characteristics of the individual plot of land. Okay, so you would want to start by saying the treatments are confounded. And here I'll put in parentheses what the treatments are. The treatments, which is the hitches, are confounded with the plots. Okay. And you would want to say something along the lines of, even though there were 25 measurements taken at random in each plot, each treatment, again, that's i.e. hitch, was only used in one plot. Okay, so that's kind of your start, and then you want to that's the intro to your explanation. And then your explanation really is just this one sentence right here. Okay. If a difference in the draft, right? So the response variable is observed, we won't know. Over here struggling with my typing. We won't know whether the difference is due to the type of hitch or the plots themselves. Or you could say, we won't know whether the difference is due to the hitch or or you could say, or other characteristics of the plots themselves. Okay. So this sentence right here is the key. This is the actual explanation as to why the plot of land is confounded the um, with or why it's a confounding variable in this experiment. Okay, and that explanation is essentially the definition of a confounding variable. Okay, so a lot of the times in statistics questions, when they ask you to explain something, they want you to take the definition of what they're talking about, which in this case is a confounding variable, and use it in the context of this study, right, or the experiment that they're talking about, right? All confounding variables deal with this idea that a variable is confounding if the difference in the response variable that is observed, if it's not possible to tell if that difference is due to your treatments and your different treatments, or if it's due to the confounding variable. All right, you all. So that is it for your studies, not studies, oh my goodness, your experiment sample FRQs. Let me know if you have any questions about this. I'm happy to answer them. I'll see y'all in the next video. Bye, everyone.